In this video, you will learn to apply the new postulates and theorem you were introduced to use the definitions of various pairs of angles from the previous lesson to find angle measures and to perform constructions that involve angles. Example 1. Use the angle addition postulate to find the measure of angle ROS if the measure of angle ROT is 119 degrees. So ROT right here is 119 degrees. In this example, you will apply the angle addition postulate using simple angle measures. So using the angle addition postulate, we know we're going to use it because we have two adjacent angles and we're given two of the three angles that are here, their measures. We've got this one that contains both of them, and then we have one of them that's part of the bigger one. So by the angle addition postulate, we write an equation using geometric language. The measure of angle ROS plus the measure of angle SOT equals the measure of angle ROT. Once we get the equation written from the angle addition postulate, then no matter what kind of numbers or algebraic expressions they throw at us, we can always plug these in or substitute them in. So here we go. The measure of angle ROS is what's in question. So we'd leave it the measure of angle ROS plus the measure of angle SOT they give us in the diagram is 58 degrees equals the measure of angle ROT, which is the largest angle here, we marked 119 degrees. Now that we have a simple one-step equation, we solve by subtracting 58 from both sides. We're left with the measure of angle ROS is equal to 61 degrees. Example 2. If the measure of angle RQT is 155 degrees, what is the measure of angle RQS and the measure of angle TQS? Okay, well this time we have two adjacent angles, but a little bit different now. We have algebraic expressions that represent these measures here and here. We're also given that the measure of angle RQT, this big angle here, this whole one here, is 155 degrees. So, using the angle addition postulate to set up an equation, we start off with the smaller angle on the left, the measure of angle RQS plus the measure of angle SQT equals the measure of angle RQT. Substituting in the values, the algebraic values for those, we have 4x minus 20 degrees plus 3x plus 14 degrees equals the measure of angle RQT, 155 degrees. Now that we have an equation substituted in for, we use Algebra 1. Drop the parentheses and combine like terms. 4x plus 3x is 7x, minus 20 plus 14 is 6 equals 155. Then by adding 6 to both sides, we get 7x equals 161. Then dividing both sides by 7, x equals 23. Now that we know what x, the value of x is, it's 23, we can substitute those back into these actual angle measures here and here, thereby answering our question. So, therefore, That's the symbol for is there. Therefore, the measure of angle RQS is equal to, it was 4x minus 20. Substituting in 23 for x, we have 4 times 23 minus 20, which gives us 92 minus 20, which gives us 72 degrees. So the measure of angle RQS is 72 degrees. And then the measure of angle TQS, the other angle they asked for, was 3x plus 14 degrees. Substituting in the value for x, we get 3 times 23 plus 14, which equals 69 plus 14, which equals 83 degrees. So the measure of angle TQS is 83 degrees. For example 3, we have angle KPL and angle JPL are a linear pair. So JPL, this one right here, and KPL, this one right here, are a linear pair, and that should be obvious because both of them together, adjacent to each other, form a line, which is the definition of a linear pair. The linear pair postulate tells us that when we add those up, or that they're supplementary, that we add them up and get 180 degrees. So they tell us what the measure of angle KPL is. It's 2x plus 24 degrees. And the measure of angle JPL, that's the other way around. The measure of angle JPL is 4x plus 36 degrees. What are the measures of angle KPL and JPL? So, by the linear pair postulate, remember, the linear pair postulate says that if you have a linear pair of angles, then they're supplementary. If they're supplementary, that means you can add them up and it should be 180 degrees. So, by that linear pair postulate, we have the measure of angle JPL plus the measure of angle KPL will equal 180 degrees. Very much like the angle addition postulate, except with the angle addition postulate, normally we don't know what this sum is. Usually we have to find the sum also. Okay, so the measure of angle JPL was 4x plus 36 degrees, plus the measure of angle KPL was 2x plus 24 degrees equals 180 degrees. Now we have an equation. Drop the parentheses. Combine like terms on the left side of the equation. 4x plus 2x is 6x. Plus 36 plus 24 is plus 60 equals 180. Subtract 60 from both sides to balance the equation. We get 6x equals 120. Divide both sides by 6 and we get x is equal to 20. Now that we have x, therefore, we can find the measures of these two angles. The measure of angle KPL was 2x plus 24, so 2x plus 24. Substituting in x is 20, we get 2 times 20 plus 24, which is 40 plus 24, which is 64 degrees. So the measure of angle KPL is 64 degrees. Then for the measure of angle JPL, we were given 4x plus 36 degrees. Substituting in x equal 20, we get 4 times 20 plus 36, which is equal to 80 plus 36, which is equal to 116. So the measure of angle JPL is 116 degrees. In example 4, you'll learn how to take a stated geometric description and to draw and label a diagram using a straight edge. You'll also learn how to use an angle bisector to solve a problem, which we've done a little bit of before. It says draw and label a diagram and then solve the problem. Ray AC bisects angle DAB. So that's the part we need to construct, or not to construct, but to draw. And then they give us some more information. The measure of angle DAB is equal to 116 degrees. Then they ask us, what is the measure of angle DAC? So let's start at the beginning. Let's get our drawing on there first. It says AC, ray AC bisects angle DAB. It doesn't really matter how big or small your angle is. For purposes of an illustration, it doesn't really matter. I'm going to make mine slightly obtuse, just out of convenience. This is angle DAB. A has to be the vertex because it's in the middle, in between the D and B. Then we have ray AD and ray AB. Now I could have switched these. I could have put B here and D here. It doesn't really matter in this one. Ray AC bisects angle DAB. So we have to estimate about where halfway between here and here would be. Right about there. And draw ray AC. It means we need point C here for ray AC. Now, these two angles, this is not a bisector until we show that these two angles are congruent to each other. Remember, an angle bisector divides an angle, this big angle, into two congruent parts. And these aren't congruent until we say they are with the arcs. Now that we have it drawn, the measure of angle DAB, that's the biggest angle, is 116 degrees. They asked for the measure of angle DAC. DAC, this one right here. The relationship between those two angles is that since this is the angle bisector, it divided the big angle into two parts, or we took 1/2 of the largest angle. So one way we could write an equation is like this. 1/2 times the measure of angle DAB would be equal to the angle we're looking for, DAC. Right there. Then substituting in the values we have 1/2 times the measure of angle DAB was 116 equals the measure of angle DAC. Now all we have to do is take half of 116, or 116 divided by 2 is another way you could look at that. When we do that, we get 58 degrees is equal to the measure of angle DAC. Example 5. In this example, you'll learn how to use algebra to solve a geometric problem involving angle measures. And this type of problem is usually the one students find more challenging when it comes to algebra. It says find the measure of two supplementary angles if the measure of one angle is 15 less than 4 times the measure of its supplement. So that we know we're dealing with supplementary angles. We've got two angles, but both those angles we don't know anything about other than their relationship with each other. So that means we're going to have two unknowns, but they're going to both have to do with one variable. So the first thing you need to do is identify the independent variable. This would be the angle that stands by itself. It's independent. So it said find the measure of two supplementary angles if the measure of one angle is 15 less than 4 times the measure of its supplement. Well, so its supplement is going to be our independent variable. I'll just use x. So let x, or x degrees, equal the measure of one angle. If that's true, that'll be its supplement. Then we're going to let, it says 15 less than 4 times the supplement. The supplement is x. 15 less than that, but 15 less than 4 times the supplement. So 4x minus 15 degrees is the measure of the other one's supplement. Now that we have both angles in terms of x, we can now write an equation by using, since these are supplementary angles, the supplementary angle definition. So by definition of supplementary angles, we have the first angle, x degrees, plus the second angle, 4x minus 15 degrees, equals, supplementary means should equal 180 degrees when we add them together. Now that you have an equation, we solve for x. Drop the parentheses, combine like terms. 1x plus 4x is 5x minus 15 equals 180. Add 15 to both sides, and when we add 15 to both sides, we get 5x equals 195. Divide both sides by 5, and x is 39. Right. Therefore, the measure of one angle was x degrees. Well, x is 39, so it was 39 degrees. And then the other one, the measure of its supplement, is equal to 4x minus 15, which, substituting in x is 39, we get 4 times 39 minus 15, which gives us 4 times 39 is 156 minus 15, which gives us 141 degrees. So the measure of the two angles that are supplementary are 39 degrees and 141 degrees. The last two examples are constructions, so make sure you have your compass and that you have some sort of straight edge, whether it's a ruler or a protractor end. For example 6, in this example you will learn how to construct an angle that's congruent, sometimes called copying an angle, to a given angle. And here we have angle A given to us. They want us to construct angle S so that angle S is congruent to angle A. So whatever this space is in between here, we want another angle the same size. To do this, only using a straight edge and compass, first thing we do is draw a ray, and it can be in any direction you want it to be, but it needs to be longer than those two rays already given to you. And label this point right here, S. Then we take our compass and we put the point of our compass on A, and you can set it anywhere you want to as long as it goes through both rays. Draw an arc through the original angle. Keep that setting, bring the point over to point S, and draw another arc going through that ray and make it long enough, it's just as long or longer than the first arc that you drew. Call these two intersection points on angle A points B and C, and call this intersection point over here, this new one on ray SR, point R. Now take your compass, come back to point C, and adjust your compass to the length between B and C, those two intersection points. Very carefully, and the accuracy is important here. Draw an arc, make sure it goes through that point. Keep the setting, bring the point of the compass over to point R, and do the same thing. Draw an arc through the arc on this other drawing here. This point right here is going to be T. Take your straight edge and now draw ray ST very carefully. This angle here, angle A, is now congruent to this angle here, angle S. Our last construction, dealing with an angle, we're given angle A. They ask us to construct angle bisector AD, or ray AD is the angle bisector of angle A. So how do we do that? Well, again, you take your compass, you set the point of your compass on point A, vertex A, and you can set your compass anywhere you want to as long as it is wide enough to go through both arcs, like that. Label these 2 points, B and C. Now take your compass once again, put the point on B, and you can either leave it the same length or you can shorten it a little bit. Don't shorten it too much. But once you set the compass now, once you start at point B, you're going to have to leave it that way the rest of this problem. So wherever you set it, leave it there, and draw an arc that's even further out from the vertex. Keep that setting, bring the point over to point C, intersection point C, and draw another arc through the arc you just drew, like that. Call that point D. Take your straight edge and draw ray AD very carefully. You'll notice it should even look like they're congruent. This angle here is congruent to this one here because ray AD is the angle bisector. So ray AD is the angle bisector or bisector of angle ABC. So angle BAD, this one right here, is congruent to angle CAD. And we have just constructed an angle bisector.